As she said, my name is Hartley McGuire, and my talk today is the ghosts of ActionView Cache. But first, a little bit about me. I am part of the Rails issues team. You may have seen my picture on GitHub. I also work at Shopify, where for the past few years, I've been on our database as a service team, which we call KSQL, which is where we run MySQL on Kubernetes. And in the past few months, I've actually had the opportunity to join the Rails infrastructure team, which is where I work today. If you have questions about contributing to Rails, our KSQL platform, or my time so far on the Rails infrastructure team, feel free to come say hi. Now, today, I won't really be talking about these things. Instead, I want to share with you a story. To really set the stage, since Rails is the one-person framework, I want you to imagine you're in the shoes of a solo developer. You've been working on a Rails application for a few years now, and this year you decide to go to Railsconf to really integrate with the community. Now, it's the night before Railsconf, and you have an idea. I should upgrade my Rails application so I can take advantage of all the cool things I'll hear about at the conference tomorrow. You upgrade your app, CI passes, it deploys to production, and you head to bed. But suddenly you're startled awake. Your phone is ringing. You're being paged. You pull up your application's dashboards and you see an error. It's coming from a controller and the code looks like this. And the error points to this cache block. Could the Rails upgrade have broken caching? But then you realize the problem is with your code. This isn't caching a query, it's caching an active record relation. The fix is simple. Make sure that the relation is loaded inside the block so that it caches the queried records. You commit the fix, but as you go to deploy, you feel a strange presence. Who's there? You exclaim, but there's no response. Finally, the silence is broken by the faintest whisper. Use ActionView. You realize that you've been visited by the ghost of ActionView past, and it's here to suggest that instead of using low-level caching with Rails.cache, you use ActionView's fragment caching. Let's see what that looks like. Instead of calling Rails cache fetch inside a model or controller, you instead move the expensive or slow queries into your view template and wrap the template render inside a cache block. And this has a few advantages. The first is that you can cache even more of your request. While the slowest part of a request may be a specific query, caching the template enables you to potentially cache even more queries. Additionally, you can cache the rendering of the final HTML. So ActionView caching makes your requests faster. Additionally, you no longer have to worry about what kind of object is being put in the cache. The bug being fixed was caused by a relation being put in the cache instead of a model. But with ActionView caching, you always cache rendered HTML, and you don't have to worry about this kind of bug at all. Now, a question you may have is, how does cache invalidation work? If the application's templates are changed and a new version of the app is deployed, how does ActionView know to render the new template instead of serving HTML from the cache? And this is an area where the magic of Rails really shines. Developers don't need to worry about cache invalidation at all because ActionView handles it for you transparently. And that is what I really want to talk about today. Cache keys are generated by a class called ActionView Digester. Let's see how it works. In this example, we'll have a product show page that renders a product model template and a list of variant model templates. To calculate the cache key for the product show template, we call the digester's digest method, which will first call the tree method to build a tree representing the template's renders. In this case, the root of the tree is the product show template, and its children are the product and variant model templates. Then the digest method uses that tree to generate the cache key. To create the key for show, we first need the cache keys for all of the children, so you can start with the product template. And since it has no children, its cache key will just be a hex digest of the source code of the template, which will look something like this. And then we move on to the next child and digest its source. And now that we've digested all of the children of the show template, we can create the final cache key by hex digesting the combination of the two children digests and the content of the show template. And this is the magic behind cache invalidation. Each template's cache key depends on the content of a template plus all of its dependencies. If any of those templates change, the cache is invalidated and the new version of the template gets rendered. Now, something I kind of glossed over is how the digester knows which templates are rendered by a template in order to create the tree. This is handled by another class called ActionView Dependency Tracker, and more specifically ERB Tracker. This class constructs this really complicated regular expression, which I put here sideways so that you can see how big it is without really trying to read it. And it extracts the template names from these render calls, and that tells the dependency tracker what the dependencies are. And naturally, because we're using regular expressions, this isn't a perfect solution, so it also provides a fallback mechanism where you can explicitly write a template's dependencies in a ERB comment. And that's how ActionView does cache invalidation. The digester constructs trees of dependencies, and the ERB tracker parses renders. Okay, we'll revisit these classes, but for now, let's go back to the story and our solo developer. As a reminder, our developer had to fix a caching bug in their application, and they've now used fragment caching to do so. Wow, they think, the conference hasn't even started, and I've already learned something to make my Rails application better. However, at this point, it's way past their bedtime, and they'd really like to get some sleep before the conference kicks off bright and early tomorrow. They push up their fragment caching bug fix, it passes CI, deploys to production, and once again, they head to bed. And of course, once again, they get paged. This time when they pull up their dashboards, they see that their application is running out of memory and restarting. Debugging memory issues can be difficult, and it's the middle of the night now, so the solo developer is interested in a quick fix. I have an idea, they think. Rails enables YJIT by default to make applications faster, but it does use more memory, so I could try turning it off and see if my memory issues go away. But before they can even open up their editor, the feeling of a strange presence returns. And this time its advice comes quickly. Use ActionView. The presence is new, but its purpose is the same, to convince you to solve your memory issues with ActionView. To understand how that's even possible, we first need to understand how Rails servers operate. Most production web servers will launch with some sort of orchestrator process that starts off by eager loading your application, and then the orchestrator will fork off a number of workers to actually handle requests. And the major benefit to this eager load then fork pattern is that the workers are able to share a lot of their memory due to an optimization called copy on write, which applies as long as the memory isn't changed. To show how important this pattern is for reducing memory usage, let's look at how Rails processes requests. When a request comes into your freshly started application, it gets routed to one of the workers. If that request requires ERB templates to be rendered, it first checks to see if the ERB template for the request has already been compiled to Ruby code. Since the application hasn't processed any requests yet, it compiles the ERB templates and renders a response. Now, what happens if that same request gets routed to a different worker? Since the ERB templates were compiled in the first worker, the second worker doesn't know they exist. So it does its own compilation of the templates and renders a response. And as requests continue to get routed to other workers, they will continue to recompile the same ERB templates and continue to increase your application's memory usage, even though the exact same templates are being compiled in each worker. So at this point, the question you are probably asking is, why doesn't Rails just compile the templates during eager load so that the memory can be shared? And the answer basically boils down to the fact that it's kind of a hard thing to do. Skipping over a ton of details of how ERB works, the important thing to know is that templates get compiled into regular Ruby methods. And one part of this process is adding a translation layer to the compiled method so that you can use locals passed into the template, just like local variables inside the template itself. But when a template is being compiled into a method, how does it know which of these things are variables and which should be method calls to view helpers? The answer is it can't know without seeing the context. the render method that actually renders the template. So for Rails to be able to precompile all of the ERB templates in your app, it would probably need something that can parse the renders. Wait a second, the ERB tracker already parses renders. Unfortunately, it doesn't quite work in this case because it only grabs the template names out of render calls, and we need to know the other arguments, the locals. Maybe the ERB tracker could be improved to parse the locals, but do we really want to tack on more regular expressions to the existing regular expressions? What if instead of using regular expressions to parse all of the Ruby code, we just use Ruby's parser? And this is exactly what John Hawthorne did in a gem called ActionView Precompiler. It uses Ruby's Ripper parser to not only extract template names from render methods, but locals as well. And because of this, it's able to compile ERB templates when the application boots, which can lower the total memory usage. The way the gem works is actually quite straightforward, so let's do a quick walkthrough. The first thing it does is it gathers all of the view templates, view helpers, and controllers in the application. The templates are found using action controller base's view paths, while controllers and helpers are found using the application's paths object. Then it uses the Ripper parser I mentioned before to parse the render calls for each of those files. And when parsing these renders, it stores the name of the template being rendered along with the local variables used as well. And once it has gathered all of the template names and locals, the only thing left to do is to actually look up the template class and call its internal compile method. And that's actually all there is to it. As a result of ActionView Precompiler, a Ripper implementation of the ERB tracker was actually upstreamed to Rails as well. And because this new tracker uses a real Ruby parser, it's able to handle many of the edge cases that the ERB tracker just can't. For example, it knows to ignore the string render if it appears in an HTML class, and it also knows to ignore renders in commented out ERB tags. And since we're talking about Ruby parsers, I also have to mention the creation of Prism, which is a brand new Ruby parser, and it became the default in Ruby 3.4. In addition to working on the parser itself, Kevin Newton also contributed Prism implementations of the Ripper parser to ActionView Precompiler and the dependency tracker in Rails. One shortcoming of the Ripper parser is that it can only be used with CRuby because other Ruby implementations have their own parsers. However, since Prism was built to be integrated with any Ruby implementation, the Prism-based render parsers are much more compatible. We've gotten a little bit off track here, so let's take a step back and summarize where we are. ActionView Precompiler can lower your application's total memory usage by compiling your ERB templates during boot instead of while processing requests. The precompiler works by parsing renders to extract template names and local variables, which it can then use to compile the templates. Now, one more time, let's continue the story of the solo developer. As a reminder, our developer had to fix their application's memory usage, and they've now used ActionView Precompiler to do so. 2 pages in one night, they exclaim, how unlucky. At least now I'll finally be able to get some sleep. They push up their ActionView Precompiler fix, it passes CI, deploys to production, and once again, they head to bed. Now, I'd say the developer gets paged again, but the next thing I'm going to tell you is how ActionView can be used to find dead code in your application, and who actually gets paged for that kind of thing. Instead, let me tell you my story. Over enough time, I think any application probably ends up with some amount of dead code, especially dead view templates. As files are moved around, new files added, old files removed, can we really guarantee that we don't leave anything behind? Around a year ago, the application I work on was going through a large migration. We were switching UI libraries. So naturally, this led to a lot of churn in our views. And by the end of the migration, the goal was every file should be rewritten or removed. But I remember there was one week in particular where there was multiple times I noticed we had some dead view templates in our application. And I created pull requests to remove them, but I knew that finding these individual files wasn't really a scalable solution to the problem. What I really wanted was a tool that I could identify all of the dead templates used in the entire application. I eventually came up with an idea to implement a mark sweep type pattern to identify which view templates must be dead. If you've never heard of mark sweep before, it's an algorithm frequently used by garbage collectors, including the default garbage collector in Ruby. And here's what that looks like. We first get a list of all view templates in the application. Then we need to create some list of root templates that we know are used. And then we iterate through that list, first marking a template itself as used, and then recursing to any templates rendered by that template and marking them as used. And this continues until the end of the root template list, at which point every template in the application is now marked as being used, or we can sweep away as dead code. I pitched this rough idea to my team, and it was enough to nerd snipe one of my teammates into writing a big, complex, regular expression that would parse the template names out of render calls inside our application's view templates. And at this point, I was like, wait a second, I've seen this one before. ActionView can already do this with the ERB tracker. With the hard part of the job already implemented in Rails, I started working on a gem. My goal was to create a CLI that you can run in your own Rails application, and it will print out the paths of any view templates that it identifies as dead. As I explained before, the first thing to implement was collecting a list of all the view templates in the application. In the CLI, you can display this list with the all flag. My first approach to creating this list was to use a directory glob so that I could avoid initializing the Rails application, but I quickly learned that this wouldn't work well for finding view templates in gems or even other Rails engines in subfolders. I ended up adding an environment require so that the application is initialized, which is unfortunately much slower than not initializing. However, it's then able to use Action Controller's view paths, which is much more accurate than the glob that I started with. The next thing to implement was recording each template's dependencies. Template dependencies can be displayed in the CLI along with their templates by passing the trees flag. For this, I created a node class that held a reference to the template name along with all of its children, which I computed using ActionView dependency tracker. And with this structure in place, it became very easy to recursively list a template's dependencies. If you think that sounds like I re-implemented ActionView digester's tree method, you would be correct. It wasn't until a few months later that I learned about the digester, but once I did, I was able to dramatically simplify my gems implementation by replacing all of my custom tree building code. The last thing to implement is collecting the list of roots, which we can identify for sure as not dead. And there are a few different approaches that can be used here, and I'll discuss the trade-offs of each. Throughout the talk, I've been referring to all view templates as templates, but really Rails makes a distinction between templates and partials. The way I think about it generally is that controllers render templates, templates render partials, and partials also render partials. The first, and I think simplest strategy, is to assume that all templates are used, but partials may not be. And as long as your application consistently only renders partials from templates or other partials, this will very accurately identify unused partials in your application. However, it also has a really high chance of false negatives, meaning that partials could be marked as used even if the template that renders them is not used. Another approach that could be used is take inspiration from ActionView precompiler. Instead of assuming that all templates are used, only mark a template as used if it will be rendered by a controller or helper. And this is a more accurate approach for templates, and therefore has a chance to remove many more dead views than if an application has many dead templates with dependencies. The downside is that views marked as dead may not actually be dead. We may have just missed the thing that renders them. Additionally, logic for parsing renders in a controller is not quite the same as the logic for parsing renders in templates. The render parser in ActionView precompiler is written to handle controller renders, but the dependency tracker in Rails is not. Finally, Turbo can also make this problem a little bit harder because it adds additional methods that can render. So if a template is only rendered by something like a broadcast, then this approach would currently mark it as dead. With either approach for determining the root templates, if you run the CLI with no arguments, you'll get either a list of dead view templates or no output at all if there aren't any. And while I don't think this is ready to be a blocking step in CI, I have had a lot of success running this against my own application. It's correctly identified view templates which are dead that account for almost 5% of the current total of view templates that we have. So that's time saved linting ERB files in CI, and it unlocks the potential to remove even more dead Ruby code in the application. Speaking of the future, I guess it's time to address that too. With ActionView already solving all of these different problems for us in the present, what more is there for it to do in the future? What I really find so compelling about these three wildly different topics, cache invalidation, precompilation, and dead code identification, is that they're all built on the same foundation. All three of these things depend on render parsing to function. And while ActionView Precompiler already defaults to using the Prism render parser when available, ActionView does not, meaning the digester and anything else that builds on it, like loose ERBs, are stuck with a suboptimal implementation. Just this month, someone opened an issue because the ERB tracker attempts and fails to parse HTML attributes that include the string render. Maybe we can improve the regular expressions to fix this edge case, but as long as regular expressions are used, there will probably still be more edge cases to fix. By switching to a real Ruby parser, we eliminate the possibility of edge cases completely. The Ripper render parser was added in Rails 7 and the Prism parser in Rails 7.2. However, there hasn't been a way for applications to even test out these improvements without using undocumented APIs. Let's fix this in Rails 8.1. The render parser should be configurable, and Prism should be the default for new applications. Something else we can improve across these areas is making the integrations tighter. As I mentioned while discussing cache invalidation, Rails magic is just doing the correct thing so that developers don't have to think about certain problems. While I talked about ActionView Precompiler today, I don't really think that you should be adding it to your gem file. You shouldn't even have to know it exists. It should just be a part of Rails. The benefits of upstreaming don't stop at increased performance. ActionView Precompiler's more advanced render parser would also benefit loose ERBs, as it would enable parsing those explicit renders in controllers. Additionally, I'd also love to see loose ERBs upstreamed in some form as well. ActionView already provides some similar rig tasks that print the dependencies of a template, and the Rails CLI also includes a command for listing unused routes. Loose ERBs would fit right in with these existing tasks to help developers understand their template's dependencies and keep their view paths nice and tidy. In addition to making loose ERBs better by upstreaming ActionView Precompiler, ActionView Precompiler also benefits from loose ERBs being upstreamed. Template precompilation means that all templates get compiled, whereas previously templates would only be compiled on use. Therefore, cleaning up unused view templates in your application means you can have even less memory usage than precompiling templates alone. Finally, I want to reemphasize how cool it is that Rails has these foundational classes that compose to solve such interesting problems. In this talk, I showed how the dependency tracker, which was first added to Rails back in 2012 for calculating cache digests, has now been repurposed 10 years later for a very different problem space. The more I reflect on this idea, the more I wonder, what else can we build? What other building blocks does Rails contain that could enable developers to solve some yet to be identified problem? So I challenge you, the next time you have a problem in your own Rails applications, to try building a solution with Rails. Learn more about all the different building blocks it provides. And if you're looking for a great place to start exploring, use ActionView. Thank you. I think we have time for questions.
Thank you. Sorry. Is ActionView Precompiler able to work with other templating languages like Slim?
That's a great question. It can if it uses the Prism render parser or the Ripper parser because it's operating on the compiled template, like the actual Ruby code. The ERB tracker cannot because it's looking specifically for ERB format things. Yeah, so if we make Prism the default, then it will work with all templating languages. Any other questions? All right, thank you for real.